Hello everyone, welcome to another video on computer graphics lecture series. And today in this series we will be seeing about line clipping algorithms. So in the previous classes we have seen two-dimensional transformations and also 2D viewing, what is window and what is viewport. In this class we will be seeing some clipping algorithms. So we saw what is clipping in the last class, removal of unwanted things which are outside the window. So if suppose this is the window, removal of things which are outside the window is known as clipping. So let us see some of the algorithms that is used by the computer for clipping. So the first one is Cohen-Sutherland line clipping algorithm. So this algorithm is actually very easy. So suppose if you take this as your clipping window, that is this as your clipping window and your image is all around here. Okay, so let us consider let us extrapolate all these lines in all four sides and let us consider the opcodes of whatever is inside as 0 0 0 0. The top one as 1 0 0 0, the bottom as 0 1 0 0, the right one as 0 0 1 0 and the left one as 0 0 0 1. So you can consider this as 4-byte codes, so which you would have studied in 12th standard. And you should also consider whatever is in the sides. So suppose if you take this side, it is in the top left hand side. So what you will take it as 1 0 0 1. So the 1 will be on the first one and 1 will be on the last byte. Similarly for all others, the top right, the bottom right and the bottom left. So how I have taken this is, for easy understanding, you can take it as north, south, east, west. So the first one will be north, the second one will be south, the third one will be east and the fourth one will be west. So or you can also consider this as top, bottom, right, left. Okay, so now we have assigned these opcodes, that is the region codes. Now let us take, suppose if there is a line which is both are inside. So a line which is completely inside the clipping window. So what we are going to do in this algorithm is, we are basically going to assign these opcodes based on where the starting and the ending points are lying. So suppose if the starting point lies here, this will be the opcode for the starting point. If the ending point lies here, then this will be the opcode for the ending point. Suppose now we'll consider a line. Okay, so let us consider a line. Let the starting point be P1 and the ending point be P2. If the line is completely inside, that is if P1 and P2 are completely inside, both their opcodes will be 0 0 0 0, right? So if both P1 and P2 have opcode 0 0 0 0, we can refer that the line is completely inside. Now let us take the second case. If P1 and P2 are non-zero, okay, so suppose if P1 is non-zero, except this all the things are non-zero. If P1 is here and P2 is inside, okay, so that time we have two conditions. We will take logical AND operation. So suppose if P1 is in this region and P2 in this region, and if you do AND operation, still you will get 0 0 0 0 only. So at that time what you have to do is, you have to check whether the AND operation is 0 or not, and if the AND operation gives a 0, you can refer that there is an intersecting point, okay, in the window. So for example, we have taken the point P1 as here and point P2 as here. So if you connect this line, you can see there is an intersecting point between the window. So you need to find this intersecting point. So you can infer this from the Cohen-Sutherland algorithm. Okay, suppose now let us take a third example, that the point P1 is here and the point P2 is in this now in this region. So visually we can say that this point lies outside. Okay, but how the computers understand this, you know that the opcode of P1 is 0 1 0 1 and the opcode of P2 is 0 1 1 0, and if you take AND operation, what you will get is 0 0 0 1 1 will become 1. So and 0 1 will become 0, 1 0 will become 0. So this is not non-zero opcode. So if it is a non-zero opcode, if P1 P2 are non-zero and also the logical AND is not zero, then we need not find the intersection point. That line is actually exterior to the window. So this is what we can understand from Cohen-Sutherland. Now let us solve a problem so that we can understand it better. Consider this problem, this example problem, where we have the window coordinates as 50, 10, 80, 10, 80, 40 and 50, 40. If you see, this is the y-axis, y minimum, and this is the y maximum. So y minimum is 50, y maximum is 80, x minimum, sorry, I told it wrong. So this is the x minimum. So x minimum is 50 and x maximum is 80. Y minimum is 10 and y maximum is 40. So this is the clipping window, and you can see there is a line going through the window. So this is P1 and P2, and also P1 and P2 coordinates are given. Visually, if you see, we know that this is an intersecting line. So, but we need to find, okay, we need to find the values of the intersecting. These values will be not given. This problem is worked out, so I have written the values here. But in the real question, this value will not be given. Okay, so we need to find this value using Cohen-Sutherland. What we need to do is, we need to the computer will verify whether this line is having an intersecting point in the window or not. So the first one, what it does is, it finds the opcode of P1. So you can see clearly that P1 lies in this region, and the opcode of this region, as we know, is 0001, and P2 lies in the above region, and that is 1000. So if you take AND operation, we know that if P1 and P2 are non-zero and the AND operation is 0, then there are intersecting points. So we need to find these intersecting points. So as I have told you, XW, so this W represents window, XW minimum is 50, XW maximum is 80, YW minimum is 10 and YW maximum is 40. You also know that we need to find the slope of the line. So that is M equals to Y2 minus Y1 divided by X2 minus X1. So Y2 is 45, Y1 is 15, X2 is 75, X1 is 40. So you get 30 by 35. So this is the slope value. So for a line equation, general line equation is actually represented by Y minus Y1 equals to M into X minus X1. So that is what, to find the Y value and X value of this intersection, I have rewritten that line formula in this manner. So if you rewrite this, it will become Y minus Y1 equals to M into X minus X1. And if you rewritten this, Y minus Y1 equals to X minus X1 into M. Okay. So I have rewritten this, the straight line equation formula in this manner to find the Y coordinate of this point and X coordinate of this point. So why I am saying like this is, this point lies in this line. So we already know the X coordinate is 50. And similarly, this point, this intersecting point lies in this line, and we know its Y coordinate as 40. So we need to just find the Y coordinate of this point and X coordinate of this point. Okay, so we'll see how we'll do that now. So it's actually very simple. As I've already told you the line equation, to find Y, we put Y equals to Y1 plus M into X minus X1. So what Y1 we are taking is this point. This P1 point's Y coordinate will be taken as Y1. Okay. The M value is 30 by 35. This can be simplified as 6 by 7. And the X value is the XW minimum value. So this value, because this point lies in, so this intersection point lies in this, this intersection point lies in this line. So we take this 50 value, we already know. So, and minus X1 is 40. So Y1 is 15. So X1 is 40. So if you calculate, you will get 23.571. This is the intersection point. So you can see clearly that this point is 50, 23.571. Similarly, the same thing can be done for X. To find the X coordinate, X equals to X1 plus Y minus Y1 divided by M. So we will take, for this X1 and Y1 value, we will take the above point. Okay, this 75 and 45 will be taken as the point. So X1 will be 75. And Y1 will be 45. Okay. So X1 will be 75 or sorry, it's this one. So x1 will be 75 and y1 will be 45, and the intersection point y is 40 because yw max is 40. So okay, so m is as usual 6 by 7. If you substitute this, you will get the value, the intersection point. So the computer can understand that this point will be 50, 23.571, and this one will be 69.2, 40. So this is COHENSUTHERLAND algorithm. So next line clipping algorithm is the LIANG-BASKY line clipping algorithm. Take this as the example. Now consider this line cutting this window, and we need to find the intersecting point. The similar opcode technique can be used to check whether there is an intersection point or if the line is completely interior or completely exterior. Okay. So in this algorithm, what we are doing is, similarly we are finding what is del y and del x. So del y is y2 minus y1 and del x is x2 minus x1. So this has some condition. So what we are doing is, we are finding 8 variables. Okay. So namely p1, p2, p3, p4, q1, q2, q3, q4. What is p1 is minus of del x. So del x, what is p2 is del x, p3 is minus del y, and p4 is del y. Okay. And what is q1 is? Q1 is x1 minus xw minimum, q2 is xw maximum minus x1, q3 is y1 minus yw minimum, q4 is yw maximum and y1. So here xw minimum is minus 3, xw maximum is 2, yw minimum is 1 and yw maximum is 6. So after finding p1, p2, p3, p4, q1, q2, q3, q4, the algorithm proceeds like this. So what we find is, we find which are all the p value that is lesser than 0. So if you see in this, we can see this p1 is lesser than 0 and p3 is lesser than 0. So we take t, a variable that is equals to maximum of 0, qk bar pk. So we saw that the first value, when k equals to 1 and k equals to 3, p value is less than 0. So what we take it is max of 0, q1 is minus 1 and p1 is minus 3. So we write it as minus 1 by minus 3, that is 1 by 3. Similarly, we found that this p3 3 value when k equals to 3 also, so we take it as 1 minus 1 by 5. So you can see clearly 1 divided by minus 5, that is minus 1 by 5. And we need to find the maximum value of these three. So 1 by 3 is the maximum value. So we take t as 1 by 3. And next we apply this formula. So x equals to x1 plus t into del x. So we get minus 3. Y equals to y1 plus t into del y. So if you substitute t value, del y, y1 value, x1 value, we will get 11 by 3 and minus 3. And similarly, we will do the next one. So what we will do is, for value pk greater than 0. Similarly, we will take t equals to minimum of 1, qk by pk. So from the above thing, we know that 2 and 4 are greater than 0. So it becomes 6 by 3 and 4 by 5. And we will find the minimum value of this one. So we will know that 4 by 5 is the minimum value among these value. So that will become t. So we'll find that x equals to x1 plus t by del x, y equals to y1 plus t by del y. If you substitute x1, y1 value, you will get minus 1.6, 6. And if you go up and see, that will be the intersection point. The first intersection point is minus, that will be the intersection point, which is minus 3, 11 by 3 will be this intersection point. And the another one, minus 1.6, 6 will be the intersection point of this one. So with this, you can find easily the intersection point using LIANG-BASKY line clipping algorithm. So that's all for this lecture. So in this lecture, we have seen 2 line clipping algorithms and how, with one example, we have seen how they were. So in the next video, we will see polygon clipping algorithm and also text clipping. So with that, unit 2 is completed. So thank you.